So now that we have an idea of what it means for one event to change another in some way, whether very noticeably or, in the case of those cards, in only a small way, we can make the distinction between events that are independent and events that are dependent. So we saw before where that conditional probability has some sort of meaning. Those would be examples of dependent events, where we say one event A depends on the other event B or vice versa, but there is some effect relationship that doing one makes the other more or less or in any way different than it would be if you just take it on its own. On the other hand, we have events that are independent if neither has any effect over the other. For example, if I take my coin here and I flip it, and just keep that in mind, whatever's going on here, we don't know yet. And then on the other hand, I take my deck of cards and I just pull a card. I don't know what this card is. I don't know what the coin flip is. But the fact that this coin flip ended up being heads doesn't affect this card being a king, at least as far as I know. There might be some weird magnetism in here, or maybe I got sold a magic deck of cards that I'm not aware of, but to my knowledge, what happened on the coin made no difference to what happened with the cards. So these events would be independent. And if you want to talk about independence in terms of conditional probability, we can say symbolically that the probability of A given B is just the probability of A, because assuming B already happened does nothing to A. And then the probability of B given A is just the probability of B, because assuming A happens does nothing to B either. And to understand this a bit more, we're going to look at some more examples for determining whether events should be classified as dependent or independent. So here we want to make the determination for the following sets of events, where for option A, we are selecting a queen. That's event A from a standard deck, not replacing it, and then selecting a king from that same deck where B is the king. The next case would be tossing a coin and getting a head, option A, and then rolling a six-sided die and obtaining a 6, that's event B, and then finally driving over 85 miles per hour, event A, and getting in a car accident, event B. Where looking at these cases, if we start with that first one, this is something that we talked about in that last example. We had that the probability of getting a king, which we're calling B in this case, given that we already had a queen, is 4 out of 51, while the probability of just getting a king is 4 out of 52. And importantly, these are not equal. So, our events are dependent. That is, the probability of getting a king, given that we already have a queen, has that dependent relationship. And when we're talking about this, usually just looking at these numbers and seeing if they match up is a quick way to check. In the second case, we want to talk about the probability of tossing a coin and getting a head, which we're calling that event A, and then rolling a die and obtaining a 6. Well, we're going to say B, in this case, is rolling a 6, and A is getting a head on a coin. Well, again, presuming we have magic coins, that would still just be 1 out of 6, which is the same as the probability of rolling a 6. Tossing the coin made no difference. So these events would have to be independent. And then finally, for that third case, we're not given numerical values here. We're not told that the probability goes up or down, although presumably some of you will be able to figure out intuitively how this one works. That if you're driving incredibly fast, maybe that means you're a safer driver. I don't know. It's usually a lie people tell themselves. But in any case, if you're driving faster, I would think that the probability of an accident is changed. So here, even though we don't have numbers to back it up specifically, faster driving should at the very least affect accidents. For most people, I would say the faster you go, the more likely you are to get in an accident just because you have less reaction time. But in general, it's fair to assume that there is some sort of effect. So we could say that the probability of getting into an accident depends on how fast you're going. But importantly for us, we would say that these events are dependent. And now that we have a sense of what we can look at in terms of one event affecting another, we're going to move into the multiplication rule to talk about what it means for two events or more than that to happen at the same time.